In this video I'm going to solve another question for AQ exam. So this is question number 3. I continue from the question 2. Now question 3, arrangement of the investigation of the equilibrium force. This is the same question about the equilibrium forces as shown in the figure 3. So we have the complete experiment process. Okay, now we have the pulleys in which there are three meshes are attached. Two meshes small m are same. This w is on this side center way. Okay, so this system is in equilibrium. Okay, now we have to answer the question 3a. The string is about 10 millimeter of the paper. Explain the technique to mark the accurately the string position on the paper. So how to mark the string position? Okay, so simple is that in order to mark this string position we use a scale, we use a mirror. Okay, for example, I use the mirror, I use a plane mirror. Okay, where I have to mark. Okay, I use the plane mirror uh, inside the string. And then, because without mirror I can't see the exact position of this string, so when I use the mirror, I see the image of this shadow of this string in this mirror. So I choose 2 points here. For example, I choose 2 points and I mark 2 points against this line. Okay, I mark 2 points on the sideways. When I mark 2 points, then I remove this mirror, I remove this mirror and join these 2 points. Okay, so that I can make a mark across. Okay, I again see that I place the mirror here. Okay, now I remove the mirror, I have 2 points. Okay, now I join these 2 points and make a cross. So similarly I take different points on this line and then join all these lines. Okay, join all these points so that they meet at a single point. There is a common point that is here. Okay, that is here. So this is the technique. We use mirror and scale to join these points so that we can mark easily. Okay, so now I can write this one in detail. I can write this one. Just 1 minute. Okay, use small plane mirror, use small plane mirror and mirror beneath the string, beneath string. Bright light source, use bright light source, bright light source to project shadow, to project shadow, to project shadow of string onto paper, string onto paper and mark points, and mark points to aid drawing lines, to aid drawing lines. Okay, now for the 3b, the crosses on that are used to determine the direction of the string. The result are shown in the figure 4b and page 13. Okay, okay, on the page 13 we have the marks, so we can draw these lines. In order we can join these lines to make the complete picture. Okay, now for the 3b1, use figure 4 in your protractor to measure angle theta. So we use protractor to measure the angle theta. So in order to find the angle theta we use simple protractor. So calculate the percentage uncertainty. So we have to calculate the percentage uncertainty. So we have to mark the this angle in order to find this angle theta. So we use the protractor. Okay, in order to find the from the protractor we use simple for the angle measure, because this is we use a line, straight line. For example, I place the protractor in here. I can place protractor here just like that. I can also take this way. Okay, this is central line, that is 0 degree. So this angle I measure, this angle, that is we can measure this line. Here is the degrees. Okay, we can here this is 31 degree. Okay, we can see that here the 0 degree to 31 degree, we can measure the angle that is 31 degree. Okay, so simple thing, from that protractor we use angle theta that is equal to 31 degree. Okay, now Parisian of the what is Parisian? Parisian mean the minimum angle the protector can measure is called the Parisian. Okay, so this is, I say that this is 1 degree. Some protector might have 0.05, but I use this protector which has the 1 degree. Minimum reading is 1 degree. So if I use 1 degree minimum Parisian, so we have to find the uncertainty, percentage uncertainty. In order to find the percentage uncertainty, we use the formula least count or Parisian divided by total angle measured multiplied by the 100%. So we get the uncertainty. So Parisian is 1 degree, total angle is 31 degree, multiplied by 100%. So we get 3.2%. So our uncertainty is 3.2%. Okay, 3b3 used figure 4 ruler to determine this. So now instead of using the protractor, we use ruler, simple ruler to make the angle theta, and using the trigonometry. So trigonometry, so I draw the figure again. For example, here is the angle, here is the, this is angle, here is the angle theta. So if this is angle theta, so this is base, this is perpendicular, this is hypotenuse. So clearly we can use any ratio. So I use sine theta is equal to perpendicular over hypotenuse. So we, from the ruler we can measure this length, that is perpendicular. So if I must use this protractor and measure the length, that is 5.1. This hypotenuse is 10 centimeter. So we use we put the value of this perpendicular is 5.1 from the protector, from the scale. We just use scale or meter ruler to determine this length, that is 5.1, perpendicular is 5.1, and hypotenuse is 10 centimeter. So theta is equal to sine inverse of this value 5.1 over 10 centimeter. So theta is equal to, that is equal to, again it is must be equal to 31 if we round off to two significant figures. So this must be equal to this protector value. Okay, same angle must be. Okay, now we continue and we discuss question 3c. The theory suggests that W is equal to 2mg cosine theta. Okay, the students produce set of result for different values m. So it means we are changing value of m, and corresponding value of theta also changes corresponding. Okay, when we change the value of m, so that the rho will be changed, so that the angle will be changed. So just to explain the graphical way to test the relationship between m and theta, we have to explain the relationship between m and theta. So if W is equal to 2mg cosine theta, so we can use cosine theta is equal to W over 2mg. So as we know that W to G are constants, so W is equal to cosine theta is equal to all constants instead of m into 1 over m, because we know that W is constant, 2 is constant, and G is constant. So m is variable, we are changing in the m. So in, we can see that cosine theta is inversely proportional to m. So it means if we want to test the relationship between theta and m, we use the graph between cosine theta and the m. We draw a graph between cosine theta and small m. It should be straight line. It should be a graph and 1 over m. It should be straight line. Why it is straight line? Because cosine theta is inversely proportional to m, but cosine theta is proportional to 1 over m. If we draw the graph between cosine theta and 1 over m, it should be the straight line. So we can test the relationship by using the graphical way. Okay, so here is the page 13. We can mark the point and we just join these points. We just join these points and we get the forces. So because here it's difficult to draw on from the laptop screen, so it is, we join this point, there is a middle point. Okay, so that's we can check this one. Okay, thank you for